Solving by graphing is obviously a bit tedious because you have to draw out a graph for every question. So we can also solve linear systems algebraically, and this is the first of two methods to solve, which is called substitution. So first I will outline the steps to using substitution and then show an example of how we can use it. And this will allow you to solve linear systems algebraically, which is a lot quicker and more efficient than graphing. So the first step is you want to label your equations. You do this just so that when you are writing your steps, it can it's just a lot clearer, and your communication of your steps is easy for me to see or for whoever is checking your solution. So I usually just label them as equation 1 and equation 2. That's kind of an optional step. As long as your work is clear, it doesn't matter if it's labeled. Then the important thing is you want to make sure that one of your equations, at least one of them, is isolated for either x or y. And this needs to be true so that you can substitute it in for a variable. So at least one equation is isolated for x or y. Okay, so an example of that would be like if the equation looked like y equals negative x plus 8, or like if you had x minus y equals 4, you could easily rearrange that to have x equals 4 plus y. Okay, so sometimes the equations are already given to you where one or both are isolated for one of your variables, and sometimes they're given to you where you can easily rearrange and isolate for one of your variables. Okay, so once you have isolated and you have one of your equations as y equals or x equals, you are going to sub in your x equals whatever your equation is, or y equals whatever the equation is, into the other equation. Okay, so in place of either your x variable or your y variable, whatever it is isolated for. Okay, so then you will isolate for that variable. Okay, so you'll simplify and solve x or y, just depending on which one you subbed in. And then the last step is going to be subbing in x or y to either equation to get your other variable. And then similar to when we are solving by graphing, you need to state your solution as a point of intersection. So you'll just state the POI as a coordinate x, y. Okay, so in words, hopefully that makes sense, but it will make a lot more sense once you see the diagram, or sorry, the example with some actual numbers. Okay, so if I take a look at this example here, I want to solve the linear system. I have two equations here. The first one is sort of in standard form, except for my c value is on the wrong side. And then my second equation is in slope-intercept form. So it's already isolated for y, so I don't need to do anything to isolate here. So what I'm going to do is I'm going to label this equation as 1, this equation as 2, and I just do this so that when I'm writing my steps, it's clear what I am doing. Okay, so then my first step is I'm going to sub equation 2 into equation 1. Okay, and so what I mean by that is here I have y equals, and it's equal to 4x minus 3. So in my first equation, I have 3x plus 2y subtract 38 equals 0. And instead of having this as a y, I'm going to substitute 4x minus 3 in there. Okay, so what that would look like is I would have 3x plus 2, and then instead of y, I'm writing 4x minus 3. It's important that you put that in brackets because you can can see in equation 1 that 2 is being multiplied by y, and in this case, y is now a binomial. It has two terms, so you need to multiply the 2 by both of those terms, the 4x and the negative 3, and then you write the rest of the equation the same. So subtract 38 equals 0, and now we just need to simplify and isolate for x. Okay, so this here, when we have the 2 in front of the bracket here, you're going to use distribution, which tells us we're going to multiply the 2 by both of the terms inside the bracket. So this will still be a 3x. Then we have 2 times 4x, so that's going to be 8x. Positive 2 times negative 3 is negative 6. Subtract 38 equals 0. Now we are going to gather our like terms. So here, be careful, we can add our terms with x's because those are our like terms, and then we can add our number terms because those are like terms. So we will have 3x plus 8x gives you 11x. And then we have negative 6 minus 38, and that gives you negative 44. And then this right side is still just 0, and then we are isolating and solving for x. So I'm going to add 44 to both sides. Now I have 11x equals 44, and then I'm going to divide by 11 on both sides to isolate for x, which gives me x is equal to 4. Okay, so that tells me that in my point of intersection, the x coordinate is going to be 4, and we know that for a coordinate, I also need a y value so that I have an actual point. So then my second step is just going to be to sub x equals 4 into either one of my equations. It doesn't matter which one you choose, 1 or 2. Usually there's one choice that's more simple to isolate for, but it doesn't matter. You'll get the same answer either way because it's the point of intersection, so it lies on both of those lines. I'm going to sub it into equation 2 just because that one's already isolated for y, so it's just a bit quicker to calculate. So I will have y equals 4, and instead of x, I'm subbing in 4 there. Subtract 3, and then I'm just calculating. So y is equal to 4 times 4 is 16, and then I'm subtracting 3. So y is equal to 13. Okay, and if you subbed x equals 4 into your first equation, you would get the same thing as well. But you can see there's just a few more steps that you would have to take to isolate. And then you can state your point of intersection, which is 4, 13, and that is your solution. This is an example of how to solve with substitution if both of your equations are already in slope-intercept form. So you can see that I have my two equations here, and they are both already isolated for y. So again, first I'm going to label my equations 1 and 2. And this looks just a little bit different from the previous example. So because they're both isolated for y, when I substitute one of the equations into the other, what that's going to look like is it's going to look like I'm just making equation 1 equal to equation 2. So my first step, I'm going to just say let equation 1 equal equation 2 and set that up. So it will look like this. I'll have negative x subtract 5 is equal to 5x plus 7. Okay, so instead of subbing it in for the variable, that's still what we're doing, but it just looks a bit different. And then we need to rearrange and isolate. So all of the x terms need to go onto one side and the y terms need to go onto the other side. Sorry, not the y terms, the numbers. So I'm going to first bring this 5x term over. So I'm subtracting 5x on this side, subtracting 5x on this side. Then I will have some negative x subtract 5x is negative 6x. And now all that's left on this side is just 7. Then I'm going to add 5 to both sides to bring this number over here, which gives me negative 6x equals 12. And then I am isolating for x, so I'm dividing this side by 6 to cancel that out. dividing it by -6, divide this side by -6 as well. And then you have x is equal to -2. And then your second step is the same as the previous example, so you're just going to sub x equals -2 into either of your equations. I'm just going to do equation 1 and then calculate what y is. So we'll have y is equal to -2. Make sure you're careful here with your signs if there's two negatives and your algebra, so that everything gets calculated correctly. So this will be y is equal to +2 subtract 5, which gives us -3. And then you can state your point of intersection, which is -2, -3. And that is your solution. This is one last example of how to use substitution, and this is showing you how to do this if neither of your equations start off being isolated for one of your variables. So in this case, I have x plus 2y equals 7, and 3x subtract 2y equals -11. So these are both in standard form to begin with. And what I'm going to do is I am going to take my first equation here, and I'm just going to rearrange it because I can see here I have x plus 2y equals 7. So my x variable already has a coefficient of 1. I just need to bring the 2y term to the other side of the equal sign so that it is isolated for x. So that would just have x left on this side. To bring the y term over to the other side, I'm going to subtract it. So I would have 7 subtract 2y. And I'm going to call this my equation 1, and this is my equation 2. Okay, so there's just that extra step at the beginning to isolate one of your equations, and then now this is the same as what we did in the first example. We are going to sub equation 1 into equation 2. So I'm going to write equation 1 here, 3, and then instead of x, I'm going to write 7 subtract 2y because that's what we see that x is equal to from equation 1. So I'll have 7 subtract 2y, and then the rest of the equation is just written the exact same. So subtract 2y is equal to -11. For the first term here, I need to use the distributive property and multiply 3 by both of these terms inside the bracket. So I will have 21 subtract 6y subtract 2y is equal to -11. And then same as in the previous examples, I'm just collecting like terms and then I'm going to isolate. The only difference here is that I'm isolating for y first and then finding x, but otherwise the steps are the same. So I will have 21. I can combine the y terms because they are like terms. So -6y subtract 2y is -8y. And then on my right side, I still have -11. Then I need to bring this over, subtract 21 on both sides, which is going to give me -32. So I'll have -8y is equal to -32. And then I'm going to divide both sides by -8 to isolate for y, which will give me y is equal to 4. Okay, so it's fine if you end up solving for y first. What you're going to do then is you're just going to sub y into either of your equations and solve for x. Okay, so my second step here, I'm going to sub y equals 4. Again, it doesn't matter which equation you choose, but it's less steps if you sub it into equation 1. And then we'll calculate for x. So we'll have x is equal to 7 subtract 2 times y, which is 4. And then we are just evaluating. So 7 subtract 2 times 4 is 8. This gives us -1. And our last step is just to state the point of intersection as a coordinate. Just be careful here because we solved for the y coordinate first and then the x coordinate, and your point always needs to be written as xy. So make sure you put the x coordinate first, then the y coordinate, and that is your solution to this linear system, -1, 4.